Okay, this is still section R.5 factoring. This is video 3, and we're going to focus on factoring by grouping. And this is typically a technique that we use if we have 4 or more terms. Okay, before we get into the nitty-gritty of factoring by grouping, I want to start off with an example. Let's just take a look at x minus 1 times x plus 3 plus x minus 1 times x squared plus 2. Okay. Directions still say factor. And this is usually a problem that gives people some trouble. When you look at this, I think it can be a little bit overwhelming. But what I want you to do is consider this as 2 terms separated by an addition sign. If I look at this product as 1 term, and this product is another, and then look at each set of parentheses as a factor, I want to identify if I have a factor common to both terms. So one factor is x minus 1 times x plus 3. Over here we have factors being multiplied together, x minus 1 times x squared plus 2. So what's in common? Well, what's in common is this factor of x minus 1. Both terms have it. So what I'm going to do is I'm going to take it out. So if I take that common factor of x minus 1 out, then what do I have left? I have a factor of x plus 3. We're adding, so plus, and a factor of x squared plus 2. Okay, so now this is all just being added here inside, so I really don't need the parentheses. I can think of this as just x plus 3 plus x squared plus 2. And now I can just combine like terms. So let's see, this would be, let's write the x squared first. I only have one x, so we'll write that down, but I can add the 3 and the 2 to give me a plus 5. So let's go ahead and bring down that x minus 1, and then this can be just written as x squared plus x plus 5. So I did it. I factored the original expression and got x minus 1 times x squared plus x plus 5. Okay, now we're going to use that when we factor by grouping. So let's check out this example. We're going to take a 4-term polynomial, 2x squared plus 4x plus 3x plus 6. Okay, always ask yourself if there's a common factor to all terms. So is there a GCF that can be factored out, from the get-go? And there is not. There's nothing common to all 4 terms, so I'm going to look at 2 terms at a time, and this is where we get the grouping name. I'm going to group 2 terms together at a time. Okay, so when I consider the 2x squared plus 4x, I do have a GCF, and it is 2x. So when I take a 2x out of 2x squared, I'm left with x, and when I take it out of 4x, I'm left with 2. Okay, let's bring down that plus sign. And I'm going to do the same thing with these 2 terms. Okay, I can take out a 3, and when I do that, I'm left with x plus 2. Okay, now does this look familiar? This should look a little bit like what we just talked about. If I consider this as 1 term and this as another, what I should see in common is this x plus 2. So I'm going to factor out the x plus 2, and then in my second set of parentheses, I'm going to write down what's left, and that is 2x, I'm adding, so plus 3. So my original 4-term polynomial factored to 2 binomials multiplied together, x plus 2 times 2x plus 3. Okay, let's try another one. Okay, let's try 3x squared plus 6x minus x minus 2. Okay, now, same thing. Is there a GCF to all four terms? There is not, so I'm going to consider grouping two terms at a time. Now, this one is a little bit more difficult, and it is because it's not all pluses. This is the sign in particular that increases the difficulty. Let's go ahead and group these first two terms. So I'm going to look at the 3x squared and the 6x. Now, this is where you need to be careful. I can't just put a parenthesis here, because if I do that, I'm just slicing off that minus sign. And technically, that's a negative x. And if I just put that parenthesis in there, I'm acting as if it's positive, as if this is x minus 2. And it's not. So what I'm going to do is I'm going to make that a plus, and I'm going to put the minus sign right next to the negative to remind me that that's a negative x. So I'll go ahead and draw my parenthesis here. Okay, now let's see what's common. 3x squared and 6x, I can take out a 3x, and when I do that, I'm left with x plus 2. Okay, now let's bring down that plus sign. Now let's consider this. I have a negative x minus 2. Okay, what's common? Well, let's see. A negative x is the same as negative 1 times x, and a negative 2 is the same as negative 1 times 2. So what's common? Negative 1. So if I take out that negative 1, what's left? X and a positive 2, so plus 2. Okay? So what do we have in common between these two terms? But x plus 2, and then what's left to go in my other parenthesis? But 3x plus negative 1, or 3x minus 1. Okay. Okay, so why don't you try to factor 9x squared minus 6x plus 3x minus 2, and we'll take a look at that one in class.